Hello calculus students and general seekers of truth, and welcome to the video on finding the volume of a solid of revolution around some axis, but this time we have multiple functions that we're dealing with here. Y equals square root of x and y equals x squared. Okay, and I've already drawn out this picture. And we're looking at this area in this region, and we're going to take that region and rotate it around the x-axis. Okay, so it's a little bit different than what we had before. So let me draw this in and make it as symmetric as I possibly can. I'm drawing underneath there since it's over the x-axis that we are rotating. That's not very symmetric. Let me clean this up just a little bit here. There you go. Maybe that looks a little bit nicer. And what we're looking for here is the volume of the region of the two in between the two. So it's kind of like if this was a glass, a very funny looking glass, we're not interested in the area or the volume that of liquid that it can hold. We're interested in the volume of the amount of the material that we need in order to make this object. Okay? So what we really have is kind of like a solid object, and then you drill a hole in it, and then you figure out what's the volume of the remaining material. So if you take a slice of this, what you really have is like a washer, hence the name washer method. You have like a circle, and then you're cutting out a little circle in the middle of that. So maybe it's easier to look at this from the top down, or like a bird's eye view of what this glass looks like. So you see you have the outer circle and then the inner circle, and then the material that we use to make this glass or the amount of material that we need depends on the area in between this. Okay, so you kind of just take a look at one slice of the object, you really have a washer. Okay, a circle with a circular hole in the middle of it. And what we're going to do is we're going to add up an infinite number of them. All we're really going to do is take an infinite number of washers, figure out what their areas are, and then add them all up. So that involves us using an integral. And it's really one of these circles, one of these washers has an area of the outer circle minus the inner circle. So we look at the big radius, which is the radius of the y equals square root x function minus the area of the inner circle, and I'm using little r here to indicate the radius of the smaller circle, the red circle in this case. Okay, so that's the area of the washer is pi big R squared minus pi little r squared, and we're going to integrate along the x direction because that makes the most sense in this case. We're stacking these washers side by side, so the limits of integration are going to be from x equals 0 to whatever this intersection point is, and I'll figure it out for you in this case. Just to speed it up, it turns out to be 1, 1. So we're going to integrate from x equals 0 to x equals 1 of this expression. So now we need to convert everything back in terms of x. Okay, so I'll do a little bit of work here. I'll factor out the pi. It's from 0 to 1 of big R squared minus little r squared. But you can see that big R is just square root of x in this case. And little r is, the y value of the red curve, which is just x squared. So I'll say that again, little r is the y value of the red curve, which is in this case x squared. So evaluating and just doing a little bit of simplification, you have the integral from 0 to 1 of big R squared, so square root of x squared is just x, minus little r squared, so x squared squared is x to the fourth, and we're integrating along the x direction. And it's simple enough in this case that we can just integrate this by hand. This is pi evaluated. The antiderivative of x is 1/2 x squared. Antiderivative of x to the fourth is 1/5 x to the fifth. And we're going to evaluate this from 0 to 1. Let me slide this over a little bit here. So you have pi times 1/2 minus 1/5. So it's 1/2 minus 2/5, so that'll give you 3/10 times pi. Okay, so that's the big idea here, is that just use this washer method when you're rotating around the area around an axis and you have an